Hello. So a few days ago, I put a short up and it got over 35,000 views. And I'm going to show you guys how I made it. So this is the short. What you're looking at is a fully procedural geometry node setup. The torus follows this track automatically. Every gate measures its distance from the torus and opens as it approaches. All the colors are generated from a single gradient. We'll turn the track shape, gate count, thickness, and timing into adjustable controls. And the only two keyframes in the entire animation move the camera. So let's get started. So here we are in a new Blender file. Just going to go and delete absolutely everything. Come up here to render, select cycles, and then here render output. Going to set 300 frames at 30 FPS. Then going to Shift A, create a curve, Bezier circle, come into geometry nodes, right click here, join left, press new to create a new geometry node setup. I'm going to rename this neon gate path. And I'm going to rename my geometry nodes as just track control. Now, in order to shape this Bezier circle, we're going to use some maths. And I will show you what it looks like. It's just right here. If we increase the wave count, it goes up and down. This track comes from three parametric equations. X and Y create the ellipse, while Z adds a sine wave around it. The value F controls how many times that wave rises and falls during one loop. So in order to do this, we're going to select our group input node and press N. Make sure we're on group here. We're going to add in a panel. We're going to rename this track controls. And then we're going to add in some input variables. The first one will be width. And this will control how far the track stretches from left to right. We want this to be a float. We'll set the default value to 7, the minimum to 1, and then the maximum to 15. I will, in the description, put the other 6 variables so you can just copy along. And their default values that I selected, their minimum and maximum. So once you've added them, it should look like this. So in order to explain what these controls do, I've actually jumped ahead a little bit and I will revert back in a second, but I'm going to explain and show you what they do. So width, if we scale this, changes its x-axis. Depth, its y-axis. The base height is how high up it is. The wave height is the amplitude of each wave. And the wave count is how many of them we have. And then the track radius is the thickness. So I'm just going to move up here and we need to add in a few nodes. So the first one's going to be a resample curve node. And this will evenly space points around this curve that you see here. We're going to need a spline parameters node. We're also going to need a set position node. And the spline parameters node will give every point a value. And the set position will actually let us reshape them points. We're going to need a curve circle node, and this will allow the small circle to become a profile swept along our path. We're going to need a curve to mesh node, and this converts the path into a visible mesh. We're going to need join geometry, and this will join all the geometries together later on when we need them. A combine XYZ node, and this will allow us to, once we've made the equations in geometry nodes, actually use the answers and the values for them equations. We're going to need 5 multiply nodes. We're going to need 2 sine nodes. We're going to need 1 cosine node. And we're going to need 1 add. And these are just basic mathematical function nodes. So they just perform the little symbol that you see in the equations. So now we're going to go make the main curve logic. So if we just take group input and resample curve and pop it in there, you should see in the viewport we now have a bit of a rough-sided circle because there's only 10 points. So let's change this count to 128 on resample curve. And then let's take the resample curve node and just pop it in set position geometry. You can also disconnect this group output. Then we can just wire set position in the group output. And you can see our curves come back again. I'm going to take curve circle, take track radius from group input and put it into the curve circle radius. And then set this resolution to about 60. Then we're going to take our curve to mesh node and take set position and add that to curve to mesh curve. We're then going to take the curve circle node curve and add it to profile curve. We can then take that curve to mesh, and add it to geometries, join geometry. And then we can pop join geometry into group output. What you should now see in your viewport is that our curve, has become a kind of donut shape. We can actually now move this track radius slider, and you can see the radius of the curve increase and decrease in size. So now we're going to go make them math equations that we saw before. So I would really recommend using frames just to keep everything neat and tidy. Select the frame and press F2, and we'll call this angle. And inside this angle frame, we need to put in the spline parameter node and a multiply node. We're going to connect factor to the first value and multiply. And then the second value, we're going to type pi asterisk 2. And this will give us the 2 pi. So now we need to go form the rest of the equation. So we're going to make another frame. And we're going to call this one x equals width times cos 2 pi t. And inside this frame, we're going to put cosine and a multiply node. We're going to connect the angle value node to cosine, put cosine to the first one and multiply. It doesn't actually matter. And then we just need to come over here and connect width to that multiply node. It's a similar setup for the y node. So new frame. And this one is y equals depth times sine 2 pi t. And inside this, we're going to add a sine node and a multiply node. Once again, connect the angle value to the sine node and the sine node to the multiply node. And then just go and grab depth and pop it in there. And then we're going to go do the same thing for z. So new frame. And z is a little bit more complicated. So this one is actually z equals base height plus wave height times sine 2 pi t, all of that multiplied by wave count. And we're going to need to pop in here a multiply node, a sine node, and another add node. And we actually need a second multiply node in here. We're going to connect the main angle to the first multiply node, and then group input wave count to the second multiply node. This is going to formulate this part, the 2 pi t times wave count. And then we're going to pop that into sine. So now we've done all this. And then we need to pop that value into multiply and grab wave height and put it into the other multiply value node. We're going to then add this value to the base height. Then we're going to combine x, y, z, and we're just going to wire these up. So x value into x, y value into y, and z value into z. And now we're just going to clean up some of this spaghetti a bit. So we're going to move that all the way over there. Grab all of these and bring them down to here. I'm going to move this and then pop the combine x, y, z into the position of set position, like so. And now if we go into our viewport, you should see we have this nice curve with a really nice looking equation. We can change the radius. We can change the wave count. We can change the wave height. We can change whereabouts it is on the z-axis, how far stretched it is on either the x and y axes. And so we're going to go back into our group input now, and we are going to add a new panel in here. And this one's going to be called runners and gates. And this one's going to be all about how the toruses move around our track up there and how the gates open. So just like before, I'll put the rest of them in the description. We're going to need 7, but I'll do the first one so you're reminded how to make them. You just press the plus sign there. Come in here and rename them. So we'll rename this one gate count. We're going to set this to be an integer. Its default I'll set as 8. The minimum I will set as 2. And the max I'll set, say, 64. And so once you've made all them, you should have 7. I've actually opened up a previous file that I had to make this tutorial, but I'm going to show you what these sliders do. So gate count increases the number of gates. Loop frames controls how many frames the animation takes to complete one full seamless loop. A lower value will make the movement faster, while a higher value will make it slower. Runner tube ratio defines how big the torus is that moves around our track. Gate tube ratio does the same for the gates. Clearance ratio defines how big the gap is between the gate and the runner. The full open distance is how far away from the gate the runner needs to be before it's at maximum opening. And the begin open distance is how far away from the gate the runner needs to be before it begins that opening animation. So now we need to go and make the gates and the runners. So to do that, we need to make some toruses, and we also need to make the clearance. So we're going to make a frame here and just call this clearance. And in this, I'm going to add a multiply node. And then I'm going to get track radius and clearance ratio and just pop them both into that multiply node. So now we need to make the runner toruses. And the way we're going to do that is we're going to add another frame here. And we're going to call this runner thickness. And inside runner thickness, we're going to need a multiply node. And we're going to wire track radius and runner tube ratio to it. Now we're going to make another frame. And I'm going to call this runner inside radius. And we're going to need an add node. I'm going to pop that in there. And then we're going to wire clearance to here and track radius. The next thing we're going to make is the runner center line radius. And we're going to need another add node. And we're going to make a final frame for this. And we're going to call this runner outside radius. And inside here, we want another add node. We're going to connect runner inside radius to runner center line radius and runner thickness to runner center line radius. Then we're going to wire runner center line radius to runner outside radius and runner thickness to runner outside radius. And we're going to just clean up some of that and add another frame and just call this runner. Now I'm going to grab this, all of these, I'm just going to pop them inside that frame, nice and neat, so that we don't get anything messed up. So once you've done that, it should look something like this. So we're going to go in and make a new frame. We're just going to call this one gate thickness. We need to add a multiply node into that. I'm going to go in and make another frame there. I'm just going to rename this gate inside radius. And inside that, I'm going to add an add node. I'm going to make another frame here. I'm just going to call that gate center line or radius, sorry. And I'm going to go and put another add node in there. Now we need to wire these up. So we're going to grab track radius again and pop in gate thickness and then gate tube ratio in the gate thickness. We're also going to get track radius again and pop it into the inside radius and then grab clearance and also pop that into the inside radius. Going to then take the inside radius and add it to the gate center line radius and also add thickness to gate center line radius like so. Then we're going to go clean all that up again. Just add another frame and call this gates. Now I'm going to just pop these in that. You should end up with something that looks a little bit like this. We're going to go add a frame again. We're going to call this one open inside radius. And inside this, we're going to add an add node. And then we're going to connect runner outside radius to the top and clearance to the bottom. And a new frame again. And this one's going to be called gate open scale. And inside this, we're going to add a divide node. And then to this divide node, we're going to connect open inside radius to the top. This is very important that it has to go into the first node. And then gate inside radius to the second. Now we're going to add another frame. And we're going to call this one full open distance. And then another frame. And we're going to call this one begin open distance. And inside these, we're going to add a multiply node to each. Should look like this when you're done. Now we're going to connect runner outside radius to full open distance. And then group input full open distance to the second one. And then we're going to add runner outside radius to the first node of begin open distance and begin open distance to the second node. Like so. Now a torus can be made from 2 curved circle nodes and 1 curved to mesh node. So if we just add a new frame And we're just going to call this one Runner Torus Creation. And inside this, we're going to need a curved circle. We're going to need two of them actually, so just copy paste it and then add a curve to mesh node. And pop all of these inside that frame. And then let's spread them out a little bit like that. So in this top curved circle here, we're going to set its resolution to 96. And in the bottom one, we're going to set its resolution to 32. And now we're just going to connect runner center line to the radius input of the first one, curved circle up at the top. And then we're going to connect runner thickness to the second one's radius input. And then we're going to take this top curved circle and connect it into curve. And we're going to take the bottom curved circle and connect it into profile curve like so. Then we're going to highlight everything and just shift D. And we're going to actually rename this to gate torus creation. And then just go and get gate thickness and put it into the bottom curved circle radius. And then just grab gate centerline radius and add it to the top curved circle. And now what I'd actually recommend you doing is just going and grabbing this join geometry in the group output. And if you just pop these mesh nodes into there and then reset some of the default values here. So pop the default values in. You should see a torus has been made in the viewport. And then you can just disconnect one and disconnect the other, and they should both disappear. Just that way you know that you've not made any mistakes. So now we need to go and animate the runner torus. And the way we're going to do that is we're going to add a scene time node in. And then we're also going to add in a subtract node. And if you just take the frame node from scene time and pop it into the top node of subtract, and then subtract the value of 1 from it. So now we're going to need a divide node. And if you take the value from that subtract node we just made and pop it into the top, and then go over to your group input and just grab loop frames, and we'll pop it into that divide node like so. And what this will do is the subtract node will take the frame that we're at and we'll start at 0. So that's why we subtract 1. And then the divide node will actually convert the current frame into progress through one complete lap of the track. Now, if you add a sample curve node, make sure it's set to factor, and come over here and grab this set positions geometry and just pop it into that sample curves curve node. If you also take this fraction value, you can apply it to factor. Now we need to add an align rotation a vector node. Set its axis to Z. It should be by default. Connect sample curves tangent to the align rotation of vectors vector node. And now we need to add a transform geometry node here. And grab your curve to mesh from the runner torus creation and output it to geometry. Connect this sample curves position node to the translation of transform geometry. And the align rotation a vector node, if you just attach that to rotation. Now, if you come over here and you grab join geometry and group output, pop it there, and just connect that transform geometry to join geometry. Make sure the loop frame is on 300, not 0. You should see the torus moving around the track like so. So now we're back in geometry nodes, and we actually need to distribute them gate toruses along the track. So if we add a curve to points, make sure it's set to count, and then take that set position geometry node from here and pop it into curve. And then if you go and get your group input, the gate count, we're going to add it to the curve to points count. Now we need an instance on points and connect this curve to points to the instance on points. And the rotation from curve to points to the rotation on instance on points. And then go up to your gate torus creation, grab the mesh, and just pop it into the instance on points. Now if we get the join geometry again and go into our viewport, we can slide this gate count and we get more gates. The issue is now the gates don't actually open as the runner gets to them. We're going to handle that next. So So in order to do that, we're going to add a position node. We're also going to add a vector math node and just select this to distance and connect position to that first vector node. And if we come over here, we just grab this sample curve position, pop it into the second one there. And now we're going to add a map range node. Make sure that the clamp is ticked. Grab this distance value node into the map range value. So now if we just come over here and we get this full open distance and put it in from min, the begin open distance to from max, and the gate open scale to 2 min. You can leave that 2 max at a value of 1. Pop this result into scale on instance on points. Go into your viewport and just make sure that you've got your default values. You should see the runners opening and closing as the torus approaches. We can maybe make it a bit smoother. So now we're going to make all 3 materials that we need for this. So if you just come into your material editor, I'm going to make a new material and call this track metal. And you do have creative freedom here, you really do. I'm going to set this to a dark grey. Metallic value to about 0.95. Its roughness I'm going to reduce to about a 0.4, something like that. I'm going to set its coat weight just down here to a 0.08. And we're going to come up here and make another material. And I'm going to call this gate resin. This is going to be our gate color. And I'm just going to reset this to its default white value. Right, I'm going to set its metallic value to 0 and really reduce that roughness to about a 0.2, something like that. I'm going to set its transmission weight over here to a 0.38, and then I'm going to change the IOR just a little bit to a 0.4. I'm going to set its coat weight to a 0.24, and its emission strength here I'm going to set as 2. I'm going to make another material, and I'm just going to call this runner resin. And I'm going to set its roughness down just a little bit more to a 0.085. And its emission strength, I'm going to actually bump up to a 3.8, just to sort of bring the eye to it a little bit more, make it a little bit more shiny. Now we just come over here and open your shader editor. Make sure that you're on the runner resin. And then I'm going to call this runner color. It's really important that you keep these names exactly as you see them, or just at least remember how you've spelt them, because later on, if you've spelled something wrong, it won't work. Align color into the base color. And then if you pop your emission down, also align color into that emission color. We're just going to go do the exact same thing for the gate resin. So input attribute. I'm going to pop color into base color, emission, color into color. And I'm going to call this gate color, like such. Don't worry if everything's just a bit black at the moment. Now we're going to go and assign all them materials that you've just seen. So go back into geometry nodes and let's pull this node tree up. So if you go and find the tracks curve to mesh node, here, this one, and then we're going to add a set material node. Just pop it in there like so, connect both of them up. And we're going to go over to the runner that we made before, just here. And just add another set material node in. Going to pop that there, just in the runner torus. If you select runner resin, and then do the same for the gate torus. So set material there, gate resin, like so. So now we need to go and procedurally generate these colors for the gate runners and the gate torus. So we're going to add in a new frame here. I'm just going to call this one gate colors. And inside this, we're going to need an index node. We're going to also need a divide node and a color ramp node. It's also probably best to make the store named attribute node right now and the realize instance node. So if we grab this index node and pop it into our frame, along with the divide node and the color ramp, just sort them out. Pop index into the first value, come to your group input and get gate count, and pop it into the second of that divide, and then wire divide into color ramp. Make sure this is set to linear, and then we're just going to go select some colors really quickly. So it's really important that the front the first and the last node in the color ramp are the same color. So just copy the hex code and paste it into there. And then let's add a few more. And you do have freedom to make your own gradient here. I'm just going to grab this store named attributes and wire color into value. And then use the same name that we made before. So gate color, like so. And I'm going to take store named attributes, come down here, and then I'm just going to pop it between this instance on points and this curve to points. Like so. Make sure this float is set to color. It's quite important. And then get your realize instance node. We're going to pop it there in between instance on points and join geometry. Now, if you just go quickly check your viewport, make sure that you're on viewport shading. You should see that the gates all have colors to them now. So now we need to go do the same thing for the runners. So let's Shift D this color ramp and then just press Alt P to unparent it. We're going to need another store named attribute node. And then we're going to take this color ramp and pop color into value as store name attribute. And if we just go all the way down here, pop them about there. What you're looking for is this scene time node into subtract divide fraction. Take the value from fraction into factor. Make sure your store named attribute set to color. And this is runner color. And then take this store named attribute node over here. Follow your runner torus creation. So set material, transform geometry, and just pop it in that transform geometry like that. And then you can unwire the other one if it doesn't automatically disconnect, like such. And if we go in our viewport, our runner is moving along the track and changing color. And our last thing to do in geometry nodes is to just actually come over here, get our resample curve, take the count, pop it into group input there. And then we're going to rename that. So press N and open your panel. We're going to rename this track resolution as such. So now we need to go and animate the camera path. One of the issues we've got is that a follow path constraint will see the original Bezier circle, not the curve produced by set positions inside geometry nodes. Therefore, we need a separate curve that copies the generated track shape. And in order to do this, we're going to add in a curve here, a Bezier circle, and we're going to rename this camera path. So the only way I could think of to actually fix this problem was to use a Python script. If you go into the description of this video, you'll find a link to a GitHub, and I'll show you how we can use that script and implement it. So if you click that link, you should be taken to this page. Press the download raw file button there. Should download it for you. Go back into Blender, open your scripting page, press open, find that downloaded file, and then press run. If I hide this neon gate path, you can see that we've now got the correct curve. We'll need to rerun this script if you make any major changes. So now we need to go and pop a camera in here and animate it. So the first thing we're going to do is add an empty plane axis. Then I'm going to grab a camera. I'm going to select the camera here, control select the empty, and then control P, set parent to object, keep transform. I'm going to select this empty with the constraints tab here. I'm going to add a follow path constraint. Select the target, be camera path, fix position, follow curve. And I'm going to go back to frame 1. I'm just going to insert a keyframe on that offset factor. I'm going to go to frame 301. I'm going to set the offset factor to 1 and insert that keyframe again. And now we just need to go into our graph editor, which is here. Select both these keyframes and set them to linear. We go back in the viewport. You should see that the camera is now attached to the empty and following the track. But this doesn't look right because if I press 0, we're not actually looking at the empty. So we need now go fix that. And the way that I'm going to fix that is if I pop down here and select camera, I'm going to add a constraint to the camera and have it track to this empty. And I'm going to grab the camera and just start rearranging its location a little bit, like such. Look through the viewport of the camera, like that. Maybe I don't like the X location as much, so I'm going to pop it over here. On C, you just play around with this if you want it to be a bit higher. And we are done. The only thing you guys have left to do is make a background that you like, maybe add HDRI or something like that. I used an infinity room, and I will show you in another tutorial how to make that. It will be quite a quick one, so stay tuned for that.